Good morning, engineers, and welcome back to another Monday. And today we will focus on optimization. So last week we modified our workflow from a solid mesh to a shell mesh. And with the shell mesh, now we will run optimization for the thickness of the part. So for that, we need to change some things in our workflow, and I will show you this in some seconds. So let me quickly share my screen. Okay, so the first thing we need to do is adding some nodes. So there is a node called parameter setup. We can also name this a proper name, saying here we want to have a thickness optimization here. And we just put this into an optimization then. Okay, for the thickness optimization, we need to add some inputs and outputs. Let's start with the output. So we want to add two different outputs. We want to optimize for the lowest mass. So just dragging out a number container here, saying mass. And this is one of our outputs, parameter setup. And the next thing is we want to allow just a displacement of 5. So the first thing we need to do is here evaluating the displacement. Okay, there is a node called evaluate result, and this is works for different results, and you can put, for example, stress responses, or in our case, we want to have the displacement response. And this one is pretty easy. The only required input are the load steps, and we already define these load steps for building up our simulation model. So pretty straightforward. And in the result node, now we have the maximum displacement, in that case as a field vector. But if we track this in the number container, it's a proper number. Displacement, check, so we can see the number here. Okay, we also need to link this to our optimization or to our parameter setup. Okay, the next thing is we need to link the thickness also as an input to the parameter set. But here we will do not a trick, but we will modify a little bit for performance. So if we would add this, it would always run through the run _CATIA node to the mid-surface TCL script. And as you have already experienced, this takes some seconds. But here we want to have a super fast optimization. So that means we add another thickness slider to our thickness option here. But we still want to keep this functionality of this end-to-end workflow, run through the run _CATIA node, run through the mid-surface TCL script. So we will give the user the decision here with a Boolean toggle to decide which of the thickness should be used. And therefore, we need to add something which is called a stream filter. The thickness, the new one, we put into input 1, the original one in input 0. And here we add this promise toggle, just saying optimization. And this one we link to the parameter set. So let me quickly explain again what's happening. So if this optimization is switched off, it sends the value 0 and means, okay, the first input will be used and going through this filter and will be streamed as an output. If we switch it on, we will use the value of this slider. Okay, just quickly let me change here to nodal displacement. And then we are already almost done. We just need to define some more things in the setup. So we want to optimize for a minimum mass, and we want to allow a displacement of max 5. So this is done. And I think we are good to start the optimization. There are also some settings you can use, here we go, to define, okay, how much of the iterations you want to do, what's the maximum runtime, and so on. So we will use, for this case, just the default settings. Okay, let's click run, and you can already see, because we have this mid-surface or this shell mesh with the really huge mesh size for this part size. This one iteration is pretty quick, and you can already see, okay, it looks like it already found our minimum thickness to reduce the weight on the lowest level, but still contains the maximum displacement. You can also see here it's design 62, and for sure we want to have this best values. So we can use here the best design. So just going here, saying deconstruct design, and then we can see all the values. Okay. So just have the names first and then the values. So the best, obviously the best thickness is 1.1. And with 1.1 thickness, we have a displacement of 4.7 and a mass of 5.6. Okay, so that was it for today. So today we learned on a pretty easy way how to do optimization. We optimize for different targets, so having one constraint, but on the same time want to reduce the masses. We could do it in even more complex cases, and we also will do it in one of the later episodes, where we will use some more advanced nodes for the optimization. But all in all, you saw it's a pretty easy way, pretty straightforward, and every engineer can use it. Say that, stay tuned, and talk to you next week, Monday. Bye-bye.